Hello everyone. Scientists around the world now agree that mankind is having an effect on the environment, and so that's what we're going to talk about today: global warming and the greenhouse effect. So, what is the greenhouse effect? Well, there has always been one. There's always been a greenhouse effect. It is how the atmosphere keeps the Earth warm. The atmosphere, you see, is like a blanket. It keeps the heat in, and for the most part, that is a good thing. Without the greenhouse effect at all, we could not survive. Too much heat would escape into space, and we could not live on Earth. It would be too cold. So you might be moved to ask, what exactly is the problem here? Why is the greenhouse effect always talked about negatively? So these are the gases that help keep the heat in. If you know a little about molecules, you might be able to identify them by looking at the structures. They are the greenhouse gases, or at least they are the most common greenhouse gases. This is a greenhouse. You may have seen one. They are used to grow plants more effectively by keeping heat in. And you can use them to grow warm weather plants in cold countries because they are that good at keeping in the heat. So this is the greenhouse effect as a diagram. Let's go through it, and we start with the energy from the sun. A lot of radiation, mostly UV, enters the atmosphere from the sun. The heat travels to the surface, where some is reflected, but most is absorbed by the Earth's surface. This heat is then re-radiated by the Earth, so the Earth gives the heat back out again when it gets too warm, but crucially, the re-radiated energy is infrared radiation, and that goes back into the atmosphere. Some of it will escape, but some of it will bounce off the greenhouse gases in the atmosphere, and it will be kept in the atmosphere, and it will be held for longer, making the atmosphere as a whole just a little bit warmer. And the more greenhouse gases there are, the more of this heat is trapped, and the warmer the Earth will get. So what are the sources of the greenhouse effect? What are those greenhouse gases that we have been talking about? The ones which produce most of the greenhouse effect are ozone, methane, carbon dioxide, which we've all heard about, and water vapor. Water vapor makes most of the greenhouse effect on Earth, and that can be 36 to 72% of the greenhouse effect. But the amount of water changes, which is why that's such a wide range of numbers. Carbon dioxide is next, and that is the most important man-made greenhouse gas, although we do produce quite a lot of water vapor too in our emissions. And it should also be mentioned that carbon dioxide can lead to more water vapor in the atmosphere by other processes as well. So the other gases after water vapor have a much smaller effect, but if you take methane as an example, it is 8 times as powerful as a greenhouse gas than water. So one molecule of methane will keep 8 times as much heat in as one molecule of water. So a small increase can have a big effect. So the natural greenhouse gases are normally in the atmosphere, and all of the gases we just talked about are natural and in the atmosphere, as well as some others. Nitrous oxide is one. That was the molecule with the blue atoms in the first slide. And all of them together help the Earth stay warm enough for us to live. But we are creating too much of these gases, and with more of them in the atmosphere, they warm the Earth too much, and this is anthropogenic climate change. So I just used the term climate change, and it's another name for global warming, although it's slightly different and I think slightly better to say climate change. The reason is, in some parts of the world, when the climate changes, it may actually get colder. Weather is a very complicated system, and it could lead to parts of the world getting colder. One example is the North Atlantic Gulf Stream, which may actually stop circulating because of global warming. And if it does, it's estimated that the Northern Atlantic countries may get around 5 degrees colder and have much more severe winter. So the amount of climate change can be even bigger than it is now, however. When we were in an ice age, the last ice age was 6 to 7 degrees colder than it is now, all around the world. And from that time, the Earth warmed up too. The problem is, it is warming up unusually quickly today. So the average temperature of the world has gone up by roughly half a degree in 25 years. These are not strictly scientific numbers, but approximate ones. So question for you, if the temperature rose like this at the end of the last ice age, how long would it have taken the ice age to end? If the temperature was 6 to 7 degrees colder than it is now, and it went up half a degree in 25 years, how long would it have taken that ice age to end? So the answer to that is, the temperature went up by half a degree in 25 years, which means it went up by 1 degree in 50 years. It needs to go up 6 degrees or 7 degrees, so 7 times 50 is around 350 years. In actual fact, the last ice age took 5,000 years to end. So you can see that the change in temperatures is unusually fast now. So where does it all come from? The Industrial Revolution. This changed the way we live, but it also made a massive increase to our emissions of greenhouse gases. In 1750, horses, or possibly our own legs, were the only way we could get around. Certainly it would be some kind of muscle power. By 1950, large parts of the world had easy access to automobiles, or cars as they're sometimes called. The difference is fossil fuels. Before we discovered fossil fuels, we used muscle-powered transportation. Horses do not create emissions except for a very small amount of methane. But from about 1800 onwards, we started to use coal and oil, and we started to make the machines that use them. First of all for production in factories, and eventually for transportation. And this is what made more emissions, and this is how we started to turn the greenhouse effect into a bad thing. So from then until now, we have only used more fossil fuels, and we have created more and more greenhouse gases, and our population has exploded with more and more people wanting to use that energy. So it's now got to the point where we are faced with a possible environmental catastrophe on a global scale. So how have greenhouse gases increased over time? We can see that greenhouse gases have increased a lot by looking at this chart. So this is slightly old data, but overall we can see that from the mid-1700s until around now, carbon dioxide has increased from 280 parts per million to 387 parts per million. And if you're wondering how we know this, we find trapped air bubbles in Arctic and Antarctic ice, and that allows us to judge how long that air has been trapped in there, and then we can analyze the composition of the air to see what the atmosphere was like back then. Another greenhouse gas that's increased is methane, from 700 parts per billion in this case to 1700 parts per billion, an increase of 150%. And remember, methane is a very powerful greenhouse gas. Nitrous oxide has also increased, although not as much and not as significantly as the other two. And then there's this new group of greenhouse gases, CFCs. Anyone know what that stands for? They have gone from 0 in 1750 to now being at 533 parts per trillion. They are greenhouse gases, but they also have other damaging effects on the ozone layer, as we will see. So as we said, water causes most of the greenhouse effect at the Earth's surface, and there's a couple of molecular representations there. So if there's a lot of water on the surface in the rivers and oceans, there is also a lot evaporated in the atmosphere. There's also carbon dioxide, which everyone's heard about, I'm sure. Carbon dioxide is the most important greenhouse gas to us because we produce such a huge amount of it each year. And as I said, carbon dioxide can actually lead to more water vapor being made in the atmosphere as well. So it's a double problem. So methane is another greenhouse gas. It's produced by animals and other decaying organic matter, as well as some volcanic processes. It's got the chemical formula CH4, that's 1 carbon and 4 hydrogen attached. And as we said before, it's 8 times more powerful than water vapor as a greenhouse gas. Another greenhouse gas is ozone, which we've probably heard about. So it's made from 3 atoms of oxygen. It has a chemical formula O3. And it protects us from UV rays, especially in the stratosphere, but it's also a powerful greenhouse gas. So nitrous oxide is a gas we have not mentioned as much. It's produced in biological processes, both anthropogenic and natural. It has a chemical formula of N2O, 2 nitrogen and 1 oxygen. Not to be confused with NO2, nitrogen dioxide, which is a common air pollutant we will also see. So nitrous oxide is not considered as important to reduce as a greenhouse gas, but we must remember that it is a greenhouse gas and it is still up there somewhere. And then the chlorofluorocarbons, CFCs. These are man-made chemicals and we have many uses for them. They're very useful, but they also destroy the ozone layer. They were banned in aerosols in the 1990s. They are now used in fridges and some other places, but they are due to be phased out completely by 2030. Here's a picture that shows what would have happened to the ozone layer if they had not been banned in aerosols. And you can see that the ozone layer would have been completely gone by 2060, or at least it's estimated. So how about going forward? Well, things are moving. In December 2009, for example, 100 world leaders, including President Obama of the USA and the Chinese Premier Wen Jiabao, signed an agreement that urgent action was needed to deal with the problems of greenhouse gas emissions. Now, signing an agreement is not legislation, and I don't know how much each of these countries has done since 2009, but it is a problem that governments are aware of, that is for certain. And I mentioned particularly the USA and China because those two countries together produce so much more energy output than all the other countries in the world. They really are necessary to solving the problem. The rest of the world cannot solve this problem without the cooperation of USA and China. Even if we do manage to find a solution though, the effects of the last 200 years will still be with us for a very long time. It's going to take a long time, if ever, for the world to recover from our industrial revolution. So there we have the principal players and factors in the greenhouse effect. And next time we're going to have a look at some of the impacts of the greenhouse effect, some of the ways that climate change and global warming are changing our lives today.